Alright, so for question 10, we have a semicircle ABCD, which means that BC is the diameter. Then we have a diameter, then the angle at the circumference is going to be 90 degrees when it's connected with the diameter. Okay, so which means that the angle ADC is not 90 degrees because AC is not a diameter. So the only 90 degrees we have is this angle BAC. We can write it down as 90 degrees. And now we have the AB is equal to AD. And we have the angle of ACD, which is equal to 21 degrees. And now we want to find out what is the angle DAC. Okay, so if we want to find out the angle of DAC, which means we need to find out what is ADC, then we can using the angle sum of triangle to find out the angle of DAC. But how can we do that? So let's try to just think about it. The only thing we have is this equal chord, isn't it? So equal chord, then we have the equal angle as well. Then we can write it down, this is equal to 21 degrees as well. And then by using the angle of sum of triangle, we can find out this is equal to 59 degrees. But it seems like it doesn't help for this angle, isn't it? Then we can try to think about it. If you have nothing to do with the pictures, you can add in some lines. So if you're adding a straight lines connecting B and D, then we can see that this BA, this BC is the diameter, so that the angle of BDC is equal to 90 degrees as well. So now we have this 90 degrees. Then the only angle we want to find it out is this ADB, isn't it? So you can see this ADB is actually watching to this arc BC, the arc AB. So you can see this ADB is watching to this AB. So is there any other angle watching to AB as well? You can see this angle ACB is watching to it as well. Then we can using the angle in the same segment, we can have this is equal to 21 degrees as well. So this part is equal to 21 degrees. Then we can say that the required angle DAC is equal to 180 minus 21 minus 21 minus 90, giving the answer of 48 degrees. So answer is going to be D. Alright, so that's for the multiple choice. So we're going to do the long questions as well. So for question 11, we have three diagrams and we need to find out what is the unknown. So first of all, for part A, we have diameter. So this is the diameter, BOC is the diameter, because BC is a straight line, and then we have the O is the center. So a straight line passing through the center is going to be the diameter, isn't it? So when we have a diameter, which means that this is going to be the 90 degrees. And then if we have this 90 degrees and we have this x, which means the only thing we want is just this angle ABO. So this angle ABO plus this angle BOD is going to be equal to 180 degrees, isn't it? Because these two are the parallel lines that we can use in the interior angle adding up to 180. Then that's done. So we can write them one by one. We first of all finding out what is ABO. Then we can write the angle of ABO plus the angle of BOD is going to be equal to 180 degrees by using the interior angles, and then AB is perpendicular to OD, so that we can say the angle of ABO is equal to 180 degrees minus 162, which is equal to 54 degrees. Then this is equal to 54 degrees. And then we can say this is equal to right angles, because as we have the BOC is the diameter. So that's the angle of BAC is equal to 90 degrees. So this is 90 degrees. Then we can, using the angle sum of triangle, we have the x is equal to 180 degrees minus 90 minus 54, then giving you the answer, which is equal to 36 degrees. Okay, so that's for question A. And then for question B, we have, we want to find out what is y. And then we have these two lines are the same. And then what we're going to have, the things that we have is this is 22 degrees. And then how can we find out y? If you see that this is the line joining from the center, joining from the chord to the center, and it's bisect the chord, which means that this is going to be the 90 degrees, isn't it? Because if we have the two lines, it's going to be bisected, and then we can say these two lines are actually perpendicular. So first of all, we can say as OB and OD are the radius, so this is equal to y, isn't it? And then is there anything else we can do? And then because this is y, and how about this angle? This angle is going to be the exterior angle, isn't it? And then we have this is equal to the right angle. Then we can, by using the angle sum of triangle, to get the whole thing. So try to write it down for part B. We first of all can say OB is equal to OD because they are the radii. And then what else we can say? And then we can say that the angle of OBD is equal to the angle of ODB. So angle of OBD is equal to the angle of ODB by using the base angles isosceles triangle. Then we can say that the angle of ODB is equal to y as well. Then after we got these two angles, we can say this is the exterior angle, isn't it? So we can say that the angle of BOM is equal to the angle of OBD plus angle of ODB, which is equal to y plus y, giving you 2y. So once again, this is angle of BOM, which is the exterior angle of this OBD, plus this angle of ODB. By using the exterior angles of the triangle, then we can say the angle of BMO is 90 degrees because it's bisect this chord. So we can say the BM is actually perpendicular to CO by using the line joining center. Line joining the center is to the midpoint of the chord. It's going to be perpendicular to the chord. So that's a long theory. So now we have this is equal to 90 degrees. So that we can say the angle of BMO is equal to 90 degrees. Then we can using our angle sum of triangle by considering this BMO. So consider the triangle BMO. We can say that the 90 degrees plus 22 degrees plus 2y is going to be equal to 180 degrees. So that the y is equal to 180 minus 90 minus 22, then divided by 2, giving you the y is equal to 34 degrees. Okay, so that's for part B. And then now we can look at part C. So part C, how can we do this? So we have this is equal to 57 degrees. This is equal to 119. Then how can you find out what is z? If you want to find out the z, which means in this triangle, ABE, the only thing need is this angle, isn't it? If we know that this angle, then we can using the angle sum of triangle. But how can we find out this angle? So this angle, we can consider this cyclic quadrilateral. So this angle is actually the opposite angle of this 119. So we can say this 2 plus together is equal to 180. Then first of all, we can find out what is B. So I just write it here for part C. So angle B is equal to 180 degrees minus 119 by using the opposite angles cyclic quadrilateral, sorry. So it's cyclic quadrilateral, and then this is equal to angle B is going to be equal to 180 minus 119, giving you 61 degrees. And then now we have this is equal to 61, so that by using the angle sum of triangle, Z plus 61 plus 57 is equal to 180 degrees. So that Z is equal to 180 minus 57 minus 61, giving you the answer is 62 degrees by using the angle sum of triangle. So that's for question 11. Then we're going to do question 12. Then the figure shows the circle of ABCD. It is given that we have the AD is parallel to BC. So we highlight that we have AD is parallel to BC. And then we have the CAD is equal to 36 degrees. CAD, where is it? So CAD, this one is equal to 36 degrees. Then also we have BDC, where is BDC? BDC is equal to 43 degrees. So anything we can do to find out the angle of angle of ACD. So this is angle of ACD. So if you want to find out this angle, the most easier way is to get this angle, isn't it? But it seems like it's not that easy to get. So is there anything else we can do? So first of all, the yellow lines are the parallel lines, and then which means that these two angles are the same. So these two angles is gonna be the same, isn't it? Then anything else we can do? So if we get this angle, then we can say we get this angle as well. So that's an easy one. So our main goal is to try to find out what's this angle. So this angle is not that easy to find, but we can find this angle instead. because these two angles are the same. They are the alternating angle. So how to find out this angle? This angle is watching to this arc DC, isn't it? And this arc DC is watching by this angle A as well. So these two angles are actually the same. So this is equal to 36. Then we can just write down what we think. So first of all, we can say that the angle of ADB is equal to the angle of DBC. So again, angle of ADB is equal to the angle of DBC by using the reason that is the alternating angles, and then we have the AD is parallel to BC. So that's the first part. And then we can say that this angle is actually equal to this angle by using the angle in the same segment. So we have the angle of DBC is actually equal to angle of DAC as well. Angle of DBC equal to the angle of DAC by using the angle in same segment. Angle in the same segment. So angle of DBC is actually equal to 36 degrees. So do the ADB is equal to 36 degrees as well. So that the angle of ADB is equal to 36 degrees. So we now get this is equal to 36 degrees, then we can say this actually using the angle sum triangle, we can get the required angle. So we considered the triangle ADC, then we can say that the required angle ACD is equal to 180 degrees minus 36 minus 36 minus 43, get the answer of 180 minus 36 minus 36 minus 43, get the answer is 65 degrees. Okay, so that's for using the angle sum triangle. Okay, so question 12 is like this. It's not that hard for this one, just think about them one by one. All right, so now we're trying to do the question 13. So in the figures, we have O is the center, and then it is given that the arc is the same. So we have the arc AB. Where is arc AB? Arc AB is here, and then we have the arc CD, so they are the same. So when you see that as the question saying that something is equal, then there's two things are equal as well. When you have the arc are the same, which means that the angle are the same as well, then we can just write it down. This angle is the same as the angle of ABC. And now we have the angle of BDC is equal to 14. So where is BDC? BDC. So angle of BDC is here. So you can say this is equal to 14 degrees. This is equal to 14 degrees. And then AOB is equal to 128. AOD is here. So AOD is equal to 128. So what we're going to find is the angle of AOB. So it's this angle. And just like what I said, because these two arcs are the same, so that this angle, required angle, is actually equal to OCD as well. So which means that if we find out what is COD, then it's actually finding out what is AOB. Then how can we do this? So if you want to find out this angle, it's actually missing this part. So what we want is to just find out this angle at the center. So this angle at the center is actually watching to this arc BC, and this BC is being watched by this angle at the circumference. So it's actually this angle is going to be equal to 28, isn't it? So this is equal to 28. Then we have the whole circle, then we're just using the angle at the point. So we just write them one by one. So first of all, we can say that's the angle of BOC is equal to the angle of BDC. So again, angle of BOC is twice of the angle of BDC. So by using the angle at the center twice angle at the circumference, then we can say that the angle of BOC is equal to 2 times 14, giving you the answer of 28. Okay, so now we can say that as the AB arc is equal to the CD arc, so that this angle is equal to this angle, then we write it down. So AB arc, as we have AB arc is equal to the CD arc, so we have the angle AOB is equal to the angle of COD. So we let it to be x, then we can say this is x plus 28 plus 128. The whole thing is going to be equal to 360 degrees. So we have x plus 128 plus 28 plus x giving you 360 degrees. So we consider at the point O. So this is by using the angle at a point. Then we can say that the 2x is going to be equal to 360 minus 128 minus 28, giving you 204, so that the required angle x is equal to AOB, which is equal to 102 degrees. So that's for question 13. All right, so then we can try to do question 14. So this one is quite hard to do with, but we just do them step by steps, okay? So first of all, we have the figure shows that the circle ABCD. So E is this point on BD, and then such that we have CD is equal to DE. So we have this CD is equal to this DE. And then when they have these two lines are the same, which means that the base angle are the same. Okay, so that's the first thing we got. And then we have the angle of ACD, So this is ACD, which is 32 degrees, which is right down. This is equal to 32 degrees. And then we have BAC is equal to 48 degrees. This is equal to 48 degrees. So we're trying to find out what is the angle of CAD and the angle of BCE. So how can we do this? Is there anything in common or anything that are the same? So first of all, we can try to think about it, because this is 48, and then this 48 is looking at the arc BC, so that this arc BC is being watched by this as well. So the first thing we can write, this is equal to 48 as well. So when we get this to 48, then we can actually get these two angles as well, because this is the base angle isosceles triangle. So we can just write it down. Each of them is equal to 180 minus 48 divided by 2, giving you 132 divided by 2. So the answer is going to be 66 degrees. So this is going to be 66. So we double check, 180 minus 48 divided by 2. So this is 66, but we already got this 32 part here. So we just write it down. What is this small part? 66 minus 32, giving you this small part is equal to 34. So now we can, and is there anything else we can do with? So what we want is this angle. So this angle is actually watching to the arc CD, and this arc is actually watching by this angle B as well. So we can say this angle is going to be the same as this angle. But is there anything we can do with that? I don't think so. So we're trying to figure another things. So how about this angle? This angle, how can we find it out? Is there anything else we can do with? Or is there something we can think about? And we still have another condition we didn't use, isn't it? We have AB is equal to BC. So AB, where's AB? AB is actually equal to BC. So which means we missed this form condition. So we have these two lines are the same as well. So we have the base angle the same. So now we got this angle as well. This is equal to 14. This is equal to 14. Then the only thing we didn't get is just this angle. So this angle is actually, how can we do this? This angle is actually equal to, there's two ways we can consider about the opposite angles, quadrilateral. So we can just think about in this way. So these two angles plus together giving you 180. So that will just minus the three things, and you can get this angle. So we have done a lot of things, then we need to try to write it down. Okay, so first of all, what we have done just having this DE equal to DC, and then so that we can say these two angles are the same. But before we're doing that, we can get this 48 as well. So where we get this 48 is getting from this angle CAB, isn't it? Because they have the angle in the same segment. So we can just write that first. So first of all, we have the angle of BDC is equal to the angle of BAC. So again, angle of BAC is equal to the angle of BDC by using the angle in same segment. So that this is equal to 48 degrees. Then as we have DE is equal to DC, which is given, then we can say that the angle of DEC is equal to the angle of DCE. So angle of DEC is equal to the angle of DCE. We can say this is by using the base angles isosceles triangle. Then we can say that each of them is equal to angle of DEC times 2 plus 48 degrees is going to be equal to 180 degrees by using the angle sum of triangle. Then we can say that the angle of DEC is going to be equal to 180 minus 48, and then we divide by 2. You got the answer is 66 degrees. So now we get this 266 degrees, isn't it? And then as we have this angle DCA is 32, so we have the angle of ACE is equal to 34. So we have the angle of ACE is equal to 66 degrees minus 32 degrees, giving you 34 degrees. And so what's the next step? We're saying that the AB is equal to BC, right? So we have this angle and this angle are the same. As we have the AB is equal to BC, they're given. So that we have the angle BAC is equal to the angle of BCA, which is equal to 48 degrees. So now we can say the required angle ECB plus this 34 degrees is equal to 48. So we have the angle of BCE, the required angle, plus 34 degrees equal to the larger angle BCA. So we have the angle of BCE is equal to 48 degrees minus 34 degrees, giving you the answer is 14 degrees. So now we can say these two angles plus together plus these three angles plus together is equal to 180. So we can write all of them down. We have the angle of DAB plus the angle of DCB, which is equal to 180 degrees. By using the what? Because these 4 points are on the circumference, then we can say this is the cyclic quadrilateral. Then the opposite angle in the cyclic quadrilateral adding up is equal to 180 degrees. So we can write it down, the opposite angles cyclic quadrilateral. Okay, so now we can say the required angle DAC is equal to 180 minus 48 minus 32 minus 34 minus 14. So the required angle DAC is equal to 180 minus 48 minus 32 minus 34 minus 14, giving you the answer is 52 degrees. Okay, so again, I think that 180 is the two angles plus together. We minus 48, minus 32, minus 34, minus 14, get the required angle. Okay, so this question is quite long, but just do it slowly down. And then every single condition, try to use it. Like what I have done is, I forgot to use this AB equal to BC, so I stuck for a while. But after you use this one, you can realize that the base angle is the same, then that's easy to do. Okay, so that's for question 14. So for the last question, question 15 is hard, okay? So in the figure, O is the center, and then we have AD is the diameter. AD is diameter, which means what? Which means we can find some 90 degrees, right? So we try to remember that. We can try to find out 90 degrees. And we have the OD and CE is actually intersect at this F. And then it's given that the ABC, this one is equal to 112. And what we're going to find is the angle of CED. CED is here. So what we're trying to find out, what is this angle? Then how can we do? Is there anything we can do first? So if you want to try to find out this angle is actually the angle at the circumference, isn't it? So the angle at circumference is watching this arc ACD, and this CD is being watched this angle at the circumference, angle at the center. So this angle is actually the double of the required angle. So we can say if this is x, then we can say this is 2x. Okay, so that's the thing we have first. And then is there any other we can have? If we want to find out this 2x, which means that we have to know what is the angle here. Because the angle at a straight lines means that if we have this angle, AOC, then we can use 180 minus this angle to get this 2x. But how can we find out this angle? This angle seems like have some relationship between 112, but actually it's the reflex angle. If we consider about the reflex angle here, this reflex angle is actually watching to the whole arc AEDC, isn't it? The whole arc here. And then this is the angle at the center. And then this is the angle of the circumference, so they are watching the same arc. So we can say that the whole thing here, the whole reflexive angle is going to be 224, so that we can say this part is going to be equal to 360 minus 224, giving you 136. Then we can actually get the 2x, right? So we can try to write it down first. So for part A, we can write it down, the reflex angle. The reflex angle what? the reflex angle AOC. Reflex angle AOC is equal to 112 times 2 equal to 224 degrees by using the angle at the center twice angle at the circumference. Angle at the circumference. Then we have this is equal to 224. Then we can say this part, the angle of AOC, not the reflex one, is equal to 360. So the angle of AOC is equal to 360 minus the reflex angle AOC. That is equal to 360 minus 224, giving you the answer is equal to 136 degrees. So now we get a 136 degrees, then we can say as we let this angle of CED be x, then we just write it down. Let the required angle CED is equal to x, so that we have the angle of COD, which is the angle of the center. So this angle of center COD is actually double the angle of the circumference. So we have angle of COD equal to 2 times of the angle of CED, which is equal to 2x, by using the theory of angle at the center twice angle at the circumference. So now we got this angle is equal to 2e. Then on this straight line AOD, we can say that 2x is equal to 180 minus 136. So we have the angle of COD is actually equal to 180 minus 136 is equal to 44 degrees by using the angle at straight line. Then we can say that the 2x is equal to 44 degrees, as we have angle COD is equal to 2x. So 2x equal to 44, which means that the x is equal to 22. So which is x? X is actually CED. So we have the angle CED is equal to 22 degrees. So now we get the part A, and now we're trying to do part B as well. So we just erase something, which is right. It's clearly, we have this is equal to 22 degrees. We have this is equal to 44. So that's the thing we have. And then we have this is equal to 112. We don't need the reflex angle anymore. So we try to find it out. If OC is parallel to ED, OC parallel to ED, which is highlighted. So we have OC is parallel to ED. Just write it down. They are parallel. And then when this is parallel, which means that this is equal to 44 as well, isn't it? So we just write it down. This is equal to 44. And then now we get a 44 degrees, and then OD is equal to 45. Where is OD? OD, so the radius is equal to 45 cm. Then we're trying to find out what is the length of DE, arc length of DE. So what we want is this arc length DE. So if you want to find out the arc length is equal to the theta divided by 360 times 2 pi r. We have the r, so what we want is just the theta. So what we want is actually just this angle EOD. That's what we want, okay? And now try to think about it. As we have, this is equal to 22, this is equal to 44. So the only thing we want is just this small angle. If we get this small angle, then which means we have to use the angle sum of triangle to get our final answer, isn't it? But try to think about it. OE and OD is actually the radius. So these two angles are the same. So basically this is just 44. All right, so we can just write it down. So for question B, we have the, what we want is the angle EOD. Then as we have this 44, how we get this 44? Because these two lines are parallel, then this is going to be the alternating angle. So we can first of all write down angle ODE is equal to the angle of COD. So angle ODE equal to the angle COD. They are the alternating angle. Alternating angle because the OC is parallel to DE. Then we can say this is equal to 44 degrees. Then next we can say OE and OD are the same because they are the radii. We have OE equal to OD, they are the radii. So that we can say the angle of ODE is equal to the angle of OED equal to 44 degrees as well. So the whole thing here is equal to 44 as well. Then we can using the angle sum triangle to find out our required angle. So that the angle of EOD is equal to 180 degrees minus 44 minus 44 to get the answer is 92 degrees by using the angle sum of triangle, so that we can say that the arc of DE is going to be equal to the theta over 360 times 2 pi r. The theta we just get is equal to 92 degrees divided by 360 times 2 pi r, which is our radius. Radius is 45. So we times the 45 again, and we're using the calculator. 2 times 45 times 92 divided by 360, then it's equal to 23 pi cm. Okay, that's it. So if you have any questions, don't hesitate to ask me.